Hello everyone, I am Professor Shivchilesh Guddodgi. Welcome you to the lecture series on database management system. We are discussing the module number 2 and the lecture number 20b. So in this video, we are going to discuss about the basic queries in SQL. In that, we are going to discuss about the select from where structure of basic SQL queries, then ambiguous attribute names, aliasing, and the tuple variables. Then third, we are going to discuss about the unspecified where clause and the use of the asterisks. And the fourth one, we are going to discuss about the tables as a sets in SQL. At the end of this lecture, the student will have a better understanding of writing the basic queries in SQL. Now, in the previous video, we have discussed about the specifying the basic constraints in SQL. In that, we have discussed about specifying the attribute constraints and the attribute defaults. So, in the specifying the attribute constraints, we have discussed about the not null. We have discussed about the check, we have discussed about the unique, and we also discussed about the default. These are the four constraints we have discussed with the attribute constraints. Then after that, you have seen how to specify the key constraints. Then after that, we have also discussed about the referential integrity constraints. The key constraints is given by using the primary key, whereas the referential integrity constraints is given by using the foreign key. And we can also give the names to the constraints, but which is a optional. But the condition is that so the total number of constraints present in the schema, it should be unique. There should not be any repetitions of the constraints name. Then finally, we have discussed about this specifying the constraints on the tuples using the check. Consider that whenever you want to check for every tuple, so that can be done by using the check constraint. Then after that, we have discussed about the schema change statements in SQL. In that, we have discussed about the drop command. So the drop command is used whenever you want to remove a table from the schema, then you can use it for the drop command. So the statement will be drop table, then you have to give the table name, then end with the semicolon. Now the second one is the alter command. So the alter command is used whenever you are modifying the base table. So the modifying the base table means either you are adding a base table or adding a column to the base table or removing a column from the base table, or if you are changing any constraint that is defined on the table. So these changes, these modification will be done by using the alter command. Okay, so these are the things we have discussed in the previous lecture. So let us see, in today's class we are going to see how to write the basic SQL queries. The SQL has one basis statement for retrieving the information the database, that is a select statement. So why the select will be used? The select will be used for retrieving the information from the database. For example, out of the 64 students, if I want to retrieve the information from the roll number 1 to 10, so that means I am selecting the students from the roll number 1 to 10, then that time you must and should use the select statement. You have to use the select statement. So this is not the same as the select operation of the operational algebra. So we also discussed about the select operation in the relational algebra. In the case of select operation in the relational algebra, it is the what we are going to do. So in that we are going to do the selection of the tuples over there. But here in this case, we are retrieving the information. So there are important distinction between the SQL and the formal relational model. So the SQL allows a table to have two or more tuples that are identical in all their attribute values. That means in the case of relational algebra, we have said that there should not be any duplicates. But what the SQL will do, the SQL will allow you to have two or more tuples that have them identical in all their attribute values. So that's why the SQL relation is a multi-set. So the multi-set means, so it is called as a bag of tuples and it is not the set of tuples. So the bag means it can allow the duplicates. If I say it is a set of tuples means there is no duplication is allowed. So the SQL can take the duplicate rows. SQL relation has considered to be the sets of specifying the primary key or unique attributes or by using the distinct option in a query. Now, the basic form of the SQL select statement is called as the mapping or a select from where block. It is a select from where block. So it is a select, here we have written it as, and then from, and next it is a where. So the select will takes the attribute list. So what is the attribute list? So attribute is the list of attribute names whose values are to be retrieved by the query. Consider that if there is a student table, if the student table has the 5 columns, out of the 5 columns, if you are only interested in the 2 values, right, roll number and the student name, so those roll number and the student name we should specify here. That means I have to write it as select. Okay, I have to write it as select, then I have to write it as roll number and the name, that is R and the name I am going to retrieve it. So now from, I need to specify the table list indicates the list of tables that you are required. So it is here in this case for displaying the roll number and the student, only one table is enough, that is a student. So I will write select roll number comma name from the table called student, from the table called student. So where after the where, the where clause will take the condition. The where clause will take the condition. So what the condition indicates here? A condition is a conditional expression that identifies the tuples to be retrieved by the query. So depending on the satisfaction of the condition, we are going to retrieve the values. For example, if I told you to retrieve the roll number and a student name of a student whose aggregate is maximum, whose CGPA is maximum. So in the case of where condition, I will put the maximum CGPA. So that is what in the case of where I will put the condition. So the select, after select, I need to specify the attribute name. From I need to specify only the table list, and in the case of where, I should specify the conditions that are there. So for all our queries discussion, we are using this schema diagram. So this is the schema for the company database. So having the table as employee, department, department location, project, then works on, then dependent. So these are the 6 tables we are going to use. We also know what are the attributes and all. And this is what the populated values look like. So populated values looks like means this is the relation state of the database. That means, so employee has the 8 rows, whereas the department has the 3 rows, department location has the 5 rows, and the works on has these many values are inserted. So on this, we are going to execute the queries and we are going to get the values. Okay. Now let us see the first query. Okay. So in the case of simple SQL queries, so the basic SQL queries corresponds to using the following operations of the relational algebra. So we are going to perform the select, then we are going to perform the project, and we are going to perform the join. Okay. So the select here in this case, it is not here in this case, the project operation will become the select of the SQL. Okay. And the where clause will become the condition, and this is select. So whatever the select they are saying, no, so this one will become the from table from where you are getting it. So all these things will be from the simple SQL queries. Now, as you can see that all the subsequent examples, we are going to use the company database only. Let us see the first example. So this is a simple query because it involves only one relation. So what the query says that we need to retrieve the birth date and the address of the employee whose name is John B. Smith. So John is a first name, B is a middle name initial, Smith is the last name. Now, the basic structure is select from where I have written it. So after the select, I need to specify the attributes. So what attribute I am going to display? So I am only interested in retrieving the birth date and the address. So that's why here I have given it as birth date and the address. Okay, because I am retrieving the information of the birth date and the address. So after specifying the select clause, I need to specify the attributes that you are going to display. So the attributes that you are going to retrieve. Now, so this birth date and the address are from which tables? As you can see that. So this birth date and address are the from the table called the employee. So that's why here I will specify the from. I need to specify the table list. So for me only one table is enough, that is employee. Employee table is enough for me. Next, after that, I am going to specify the condition because the third part will be the where clause. After the where, I need to specify the condition. So what condition they have given? So whose name is John B. Smith. So as I said that John will be the first name. Okay. Then I need to put the condition and, because so combination of 3 should be true, then only we are going to retrieve it. So then middle initial is a B and last name is a Smith. If this condition is specified, then we are going to retrieve the birth date and address of a employee. So this is similar to the select project pair of the relational algebra operation. The select clause specifies the projection attributes and the where clause specifies the selection condition. However, the result of a query may contain the duplicate tuples, but in the case of relational algebra, which is not possible. Now, let us see the query number 1. So here in this case, we are interested to retrieve the name and the address of all employees who work for the research department. Okay. So the research department, that is the name of the department, is present in the table called department. So that means I need to have two tables. One is the employee and second one is the department. Okay, and I'm retrieving the name. So the name means always we are going to consider only the first name and the last name. Remember, so whenever I say that name, so you need to consider it as the first name and the last name. And also I'm interested in the address. So here I have taken it as address. So 3 attributes I'm retrieving. No. From which table I'm taking? So I'm taking it from the table called employee, because why employee is required? So because the F name, L name, address are from the table called the employee. And the next one, I also require the department. So why the department is required? So the department is required because I'm interested in the employees who are working in the research department. So if I want to see the department name, so the department name is present in the table called the department. So that's why I need to consider the department. Now, so that's why you can see that in the where I am putting the condition as department name is equals to research, and also I need to join the employee table as well as the department table. I need to join them. I need to combine them. So how we are going to combine those two tables? I am going to combine those two tables by using the attribute called D number is equals to DN. So using this condition, I am going to combine the employee table and the department table. So in the previous example, we have only taken a single relation, that is a single table employee. But in this example, we have taken the two tables, that is the employee and the department. Okay. Now, here in this case, what is the difference between the previous two example and this one? So here in this case, we are concentrating on the three relations, three tables. So that is what, for every project located in the Stafford. So list the project numbers and the controlling department number and the department manager's last name, comma, address and the birth date we need to retrieve it. Okay, here in this case, as you can see that we need to list the project number, so that's why I have written it as P number. And he also says that controlling department number, that means I should display the department number. Then he says that department manager's last name, so that's why I am displaying the last name. It says that then I also need to display the birth date. I have taken it as birth date, and also I need to display the address. Here I have taken the address. So these are the attributes I am interested to retrieve from the database. This project number is from the table called the project, so that's why I have taken the table here as project. Then the department number is from the table called the department, whereas the last name, birth date and address are from the table called the employee. So totally how many relations are required for me? So totally three relations are required. Now after that I need to combine these three tables. Whenever you are combining the three tables, so to minimum two joins are required. Okay, if there are two tables, so one join is enough. If there are three tables, you need to have the two joins. If there are four, then it will be the three. So always the number of joins will be one less than the number of tables listed. Okay, so here in this case I am combining the project table and the department table by using the attribute called the dnum is equals to d number, and I'm also combining the department with the employee by using the manager SSN is equals to SSN, and here in this case, and I'm also wanted the P location is equals to the Stafford. So these are the conditions to be given. Okay, so there are two joint conditions. So one is the D number equals to D number, which relates the project and the controlling department, and for the manager SSN with the SSN, which relates to the controlling department with the employee. That means three tables are there, so two joints is necessary. After the basic query structure having involving only one relation, two relation and the three relation, now let us move for the aliasing and using of the asterisk and the distinct and the empty where clause, what it means. In SQL, we can use the same name for two attributes as long as the attributes are in a different relation. For example, so the employee can also have the attribute as a name, and the department can also have the attribute as a name. There is no any problem because this name is from the employee and this name is from the department. So that will be a no problem. Okay. Now, there are some situations. Consider that a query that refers to two or more attributes with the same name must qualify the attribute name with the relation name by prefixing the relation name to the attribute name. For example, as I said that the name is there in an employee, that means I should first prefix it. I must and should prefix it with the qualifier. So that is what the employee dot L name, or you also specify it as department dot D name. Okay. For example, if I just write it as the Shiva. Okay, I don't know from which Shiva it is there, so that's why I need to qualify it. For example, if I write it as Asha, whether I'm referring it to the Asha Devreddy or whether I'm referring it to the Asha Gaonkar, I doesn't know. That's why I need to qualify it. How we are going to qualify it? I will write it as Gaonkar dot Asha, or I will write it as Devreddy dot Asha. So this one we call it as qualifying or prefixing the table name at the beginning. So that means If you have prefixed with the table name, then you can use the same name any number of times, then there is no problem. Now you can also do the aliasing. Aliases means you can give a different name to a relation. Consider that the some queries need to refer to the same relation twice. Consider that if you are using the supervision relation, so we are referring to the employee table twice. One as the supervisee, another one as the supervisor. So then that time the aliasing will help you to understand the query in a better way. For example, you can see here, for each employee, retrieve the employee's name and the name of his or her immediate supervisor. Okay. Now here in this case, I am selecting the e.f name. So e.f name means we are qualifying the attribute. So here E is indicating, as you can see. So the table we are taking it as the employee. So the employee I am giving another name as E and S. So what these E and S we call it as aliasing. So what is that aliasing? So instead of writing the complete table name as the employee, then I can write it as E. So the E indicates the employee, S indicates the supervisor. Either you can give the E or you can give the S. The same name table employee has the two other names, one as E, another one as the S. Okay, here the E dot F name and the E dot L name indicates that. So I am displaying the employee's first name and I'm also displaying the employee's last name. Now I also want to display the immediate supervisor first name and the last name. To display the supervisor's first name and the last name, I am using the S. I will write it as S dot F name and S dot L name. I need to combine these two tables. That is what E dot super SSN is equals to E dot SSN. So what it indicates, the table, instead of writing the complete full name, I can alias them and I can use it. For example, if there is a long table name, so typing complete table name, it will be a hectic one. So just I will rename it as small single letter. So the alternative relations E and S, here we call it as the aliases or tuple variables for the employee relation. So what is that E and S? So that we can think of E and S as two different copies of the employee. E represents the employee's role of the supervisors and S represent the employee's role of supervisors. These are the two copies of the employee only. So aliasing can also be done in a SQL query for our convenience. For example, as you can see that we can also use the as keyword. So what that as indicates, as means it is once again the aliasing. Instead of writing the complete aliasing, you can just write it as, or even if you skip the as, then also it is fine. You need to give the table name, then one space, then you give the aliasing name, either E or S, whatever you wish. Okay, that is fine. Or you can also write employee space, you can write it as Shiva. So instead of writing the employee table, I can also write the Shiva. That is no problem. Now, till now we have seen that usually the basic structure of the SQL will have the three components. The first one is the select, second one is the from, third one is the where. So as you can see that the where clause is not a mandatory one. It is the optional. You want to have or you can also leave. So if you have not specified the where clause, then what happens? So if there is a missing where clause indicates no condition, hence all the tuples of the relations in the from clause are selected. So that means, so this is equivalent to where is always true. Okay, if I am not specifying any where clause means that indicates the where will be always true. So here in this case, as you can see the query, we are retrieving the SSN values of all employees. So here in this case, select, I need to specify the attribute name. Here from I have specified the employee. So here there is a where is missing here. So where is missing means I need to display the all the SSN of the employee table. Okay, So that is what the where will be. If you remove the where, so all the things will be listed. If more than one relation is specified in the from clause and there is no join condition, then what it results? It results in a Cartesian product of the tuples is selected. So the next one is here in this case. As you can see that we have two tables are there, employee and the department, and you have not specified the where clause here. So then what happens here? So it is extremely important not to overlook the specifying the any selection and the join conditions in the where clause. Otherwise the incorrect or very large relations may result. So as there is no any where condition is there in this case, so we are going to get the Cartesian product of employee and the department, and we are going to get the incorrect result. So that's why it is always preferred to use the where clause. Okay. Now, so till now we are seeing that in all the examples we are specifying the SSN and the D name in the case of select. That means whatever the attributes we are interested. Consider that if you want to retrieve the all the attributes, if you are interested to display the all the attributes of the tables of the selected tables, then you need to use the asterisk, which is like a wild character, which stands for the all the attributes. What that star indicates, it will indicate all the attributes. For example, if I write select a star from employee whose department number is equals to 5, so whatever the columns that are there in the employee, all the columns, all the attributes will be displayed. Same in the second case also, all the attributes from the employee and the department after the where clause is satisfied, all the attributes will be displayed. So this is what, whenever you want to display all the attributes, then instead of writing all the attribute names, so you better use only the asterisks. Now, you can also use the distinct. So what that distinct will do? So the SQL does not treat a relation as a set. So the duplicate tuples can appear. As I said that. So the SQL here considering it as a multi-set or a bag. That means the bag will have the duplicates. Whereas in the relational algebra, consider it as a set. Set does not allow the duplicates, whereas SQL allows the duplicates. Remember. To eliminate these duplicates, we must and should use the distinct keyword. So what the distinct will do? So the distinct will eliminate the duplicate tuples in a query. Consider that if there is a Abhay, if it has appeared 4 times, if I use the distinct keyword, so the Abhay will appear only one time. The Abhay will appear only one time. For example, select a salary from the employee. So here in this case, all the salaries will be listed. Consider that if the 30 has appeared 4 times, 35 appeared as 2 times, and the 40 has appeared the 2 times. Then totally 8 times will be displayed. Now, if I use the distinct keyword here, so that means we are only going to display the 3 values. One as the 30,000, another one as the 35,000, and third one as the 40,000. So this is what the difference of using the distinct. It will only have the unique values, or you can say it will eliminate the duplicates. Now, SQL has directly incorporated the sum of the operations, like you can perform the union operation. In some versions of SQL, there are some set difference, that is a minus, and you can also perform the intersection. So the resulting relations of these set operations are sets of tuples. That means duplicate tuples are eliminated from the results. The set of operations may apply to union compatible relations. So that means the two relations must have the same attributes and the attribute must appear in the same order. So the same order means if it is a first name, middle initial and the last name, so it should be also be appeared in the same second relation also in the same order only. For example, we have taken one example to demonstrate the union set operation. So the query says that we need to make a list of all the project numbers for the projects that involve employee whose last name is the Smith as a worker or as a manager of the department that controls the project. The query will be, first we have to consider one as the worker and another one as the project, then I have to perform the union operation. So that is what I have performed here. So select P name from the project, department and the employee, and I'm specifying, as there are three tables, so two joins are necessary. So first I am connecting the project with the department, then I'm connecting the department with the employee, and also I'm specifying the last name is equals to the Smith. So this one you are considering it as a manager. Now I also consider it a Smith as a worker. For that I will consider select P name. Once again I need to consider the tables as a project, works on and the employee. So once again, as there are three tables, so two joins are necessary. First I will combine the project table and the works on table. Then I will combine the works on table with the employee table, and also I am considering the name equals to Smith. So this is part will give the Smith as a worker, and this part will give the Smith as a manager. I have to perform the union operation to get the complete result set. To summarize the things what you have discussed in the today's video is that, so the select from where structure will be used for retrieving the basic SQL. So after the select, I need to specify the attribute list. From clause will take the table list, and whereas the where will take the conditions. So if there is a ambiguity in the attributes, so the attribute should be prefixed with the table name. That means we should qualify the attribute. So then we can also alias the tables by using the keyword as, or I can also consider them as the tuple variables. So whenever if the where clause is not used, that means we are going to consider all the values. And whenever you want to display the all the attributes, so we need to use the asterisk. And in SQL we can perform the union operation, minus operation and the intersection operation. So thank you.